Now we come to the last chapter of Physics 1, that is the chapter about the heat engines, entropy, and the second law of thermodynamics. In chapter 20, we talk about the first law of thermodynamics, which tells us that we can change the form of energy, and if we take into account of the all form of energy, we must have the conservation of energy. The first law expresses the conservation of energy in the general form that includes all kind of process, the mechanical process and thermal process. Now, for the second law of thermodynamics, we will talk about the direction of the energy transfer. In first law, there is no information about the direction of the energy transfer. For the second law, we will discuss what process is possible, what direction of energy transfer is possible, and what direction is impossible. The concept of the second law is closely related to the concept of heat engine. The heat engine is the engine that we input the heat into the engine and is transform it into the mechanical work. So we will start the chapter with the definition of the heat engine. The definition of the heat engine and the second law of thermodynamics. Next, we go to the what we may say that the reverse process of the heat engine, that is the heat pump. In the heat engine, we input the heat into the system and it gives back the mechanical work. In the heat pump, we input the mechanical work and then it transfer heat from one region to another region. It can be both direction, that is, it transfer heat from colder region to the hotter region, in the sense that we want to use the heat like a heater, that we need the heat, or we want to get rid of the heat like in the refrigerator, so we take away the heat inside the refrigerator. So there are two versions of heat pump, the heat pump and the refrigerator. Next, we go to the very important concept in thermodynamics, the reversible process, which is the process that we can do the analytic using the equation of the thermodynamics. But most of the process happen in the nature is an irreversible process, that the process that cannot reverse by itself, but you need to put the external effort to reverse the process. So the reversible process is like a model that we use to study the nature, so we can have the rough idea what the nature work, but in the real situation it's the irreversible process. One of the most important reversible process is the process in the ideal heat engine, which we call the Carnot engine. Carnot is the name of the engineer that do the analysis of the heat engine and express that there is an ideal engine that gives the maximum efficiency of the heat engine. The real heat engine cannot reach this maximum efficiency, and that ideal maximum efficiency engine is called Carnot engine, to honor the Carnot. The real engine, like the gasoline and diesel engine, will give the less efficiency than the Carnot engine, but it is practical in the sense that we cannot build the Carnot engine to work in the real situation. So the purpose of the design of the heat engine is to reach as close as possible to the Carnot engine. For the last 3 sections, we will talk about the very abstract concept that is the entropy. And from this concept, we can define the direction of the process, that which direction is possible and which direction is not possible. So this entropy will be related to the second law, and we can also define the entropy in the microscopic scale, which at the end we will see that the entropy is related to the disorder of the system, and the system is tend to be in the disorder state. If we do nothing to the system will tend to the to approach the maximum disorder state, and we will get one of the most important principles in physics, the maximum entropy principle. Okay, so that is what we will discuss in this chapter.